Hello, everybody. Good afternoon, good morning. It is afternoon for me, or good evening wherever you guys are at in your time schedule. We're going to go ahead and begin with Module 7, and this example will be kind of a, we'll hit the PowerPoints, but we'll get into demonstration as part of that. And one of the things, that I want to talk about is why inheritance. And before we can even get to why inheritance, we have to talk about what it is first. So we'll get onto the whiteboard and we'll discuss why and what it actually helps us do in the programming field. And then we'll get into, as part of that demonstration and whiteboard stuff, we'll get into the polymorphism. One thing that we won't be talking about that is an important aspect of building technology with object inheritance and polymorphism is dynamic binding, but Python doesn't allow dynamic binding, so we won't even talk about that. That's going a little bit too far. And also, Python is an object-based language. It's basically it's a band-aid slapped on to make it so that we can do objects, and it gets better over time, and it will. So without any more time, let's get into it. Inheritance is when you have two objects, and one object is kind of be like a blueprint for what the other object is, or adds on to the blueprint. So essentially, think about insects, and insects are incidentally part of the animal class. And what you can do, and we're right on the whiteboard time right now. Let's get the insect terminology in there with base classes, and we'll add to it as well. So let's say that we have an animal class, an animal object. So when I say class, I'm also talking about an object. And when we think about inheritance, it happens on a hierarchy, and what we have is we call it a base class, a superclass, subclass. There's all kinds of different terminologies. I prefer base and derived terminologies. Your Python uses subclass and I believe super. I believe that's correct. We'll get into it here as soon. But so the base class is kind of the blueprint. So we would create an animal object, and this animal object would have everything that we need to represent an animal in with numbers, because remember, everything's a number. And we would have things inside of the animal class like number of legs. How many legs does this animal have? Is it a two-legged animal? Is it a four-legged animal? Is it a six-legged animal? And you're like, well, Mr. B, what are you talking about, six-legged animal? You're nuts. Well, incidentally, it's kind of a fun fact. Animals and insects. An insect is considered an animal in the kingdoms. So here's what happens: is with your base class, you build everything that an animal needs, and then when you use it as a blueprint to inherit from that lower level class, you're essentially taking on all its attributes. So in other words, you can write one bit of code that is called an animal, and then you can take that bit of code and you can branch off of that animal class and create another object called insect. But here's what's the key: is whenever you have a base class, your lower level class in the hierarchy, when you inherit from it, it always needs to go from generic. So this it would be the generic. The bottom level class in the hierarchy would be generic. Some generic attributes, such as number of legs. And then as you inherit from those lower level classes in the inheritance chain, because there is no such thing as multiple inheritance, it's chained inheritance, you can have another, or what you would do then is an insect would then define whether it has, we may need to set an array in here that describes number of legs, and you would have a list of the number of legs in the animal, and then here you would create the 6 legs, because here you have the general, the animal's going to have legs. Here you have the specific, you actually have 6 legs for an insect. And that's just an idea, and it's not the best example. So let's go with something a little bit less difficult. So one attribute an animal would have, that all animals would have, is a weight. So even an insect would have a weight. And so that's where you want to be generic, is all animals have weight. However, what separates out an insect from all other animals? And maybe it could be something as generic as, we could call it a hardness value. A hardness value may refer to the exoskeleton's its shell and how hard it is. Something like that. And so what we have is we have generic attributes to more specific as we go up the chain. Now, we can get more specific as we keep going up the chain. We have now B that takes on all the attributes of an insect. But what sets it apart? Well, it could have stinger size. I don't even know what you want to call it, but it could have a size variable in here, an S size variable, to refer to its the width or the length of its stinger. I don't even know what the scientific name is for that. But you see where everything that we built for an animal, the weight attribute, also comes in and it's part of the insect. Because we're inheriting the insect from animal, and therefore it inherits that attribute weight. And that's why you need to go from general to your lower level classes to more specific as you create an inheritance chain. And that's kind of the idea of inheritance. And so what you do is when you're inheriting from another object, you're essentially taking on all the lower level objects, functions that are available to it, and data. So you get it all. And then you can build an animal class. And let's say we're making a game, a farm game, some kind of silly farm game. And we have animals on the farm. Well, we would want to build an object called animal for everything that would describe the animal, its size, its weight, that is all an attribute that all animals have. And therefore we wouldn't have to rewrite all the code for the animal. Then we would have to take and just copy and paste all that code that makes up an animal into the insect class. So why can't we just write the animal code and reuse this code in the insect class? And that's where inheritance comes in. It helps for rapidly developing code bases. And it's actually where whole technologies are built, and we'll get to that in a little bit. Let's follow along with our example here, because I can continue to do this. I can continue, and this could be a cow. Okay, my cow drawing is not very good. I get it. Okay, cow. That's a cow. And then what could we be even more specific about the type of cow? Yeah, we can inherit from here, and we can say this is a milk cow. And we can even be more specific. We could say this is a bull. Okay, now we can't do this. We can't have another class over here that is something. You know, it could be what would go with this kind of scheme? Something like a rock. It doesn't matter. We could even make it a standalone animal type, like a tiger or whatever. And let's say that we consider it a base class, a lower level class, and or a subclass. We can't say that cow inherits both from animal and a rock or a tiger or anything else. It doesn't matter what is in here. It doesn't matter. It could be any kind of object. It could be something that we would want a cow to have, like, let's say, well, I don't want to get too far in it, because here's where the problem is this is what we consider multiple inheritance, where one derived object inherits from its lower level base classes twice. This is not possible. And the reason why it's not possible is because of dynamic binding. Now, we can't go into dynamic binding, so I'm just going to say that it's not possible and leave it at that. However, what we do consider multiple inheritance to be is this chained inheritance behavior. You see how it's kind of chained? And we put another chain in. That's what I would be referring to as multiple inheritance. You cannot do this type of inheritance. You can't have one class that inherits from two different lower level classes. You just can't. So it's all about a hierarchy of going from a generic value to something that is more specific. Something that is more specific. And then something that is even more specific here as you go up the chain. So something more specific, like a bee is an insect that's an animal, but it's very specific compared to the insect class or the animal. And we could even have out here, we can even go more specific. Oh my goodness, where's my silly thing? We can call this one, we can have another class that goes out here that inherits from that one, and we call this a queen. So you can have in classes that are inherited, and so this class's base class is bee, and this class's base class is insect, or lower level class, and you know. So let's get back to the PowerPoint so I can make sure that we work with the Python terminology here as we get through. So here's an example of insects: a bee, a grasshopper, and they have certain characteristics that make it up as an insect. However, a bee is different from a grasshopper. So when we think about objects, we are talking about the characteristics going from general to more specific. So this is a really highly important topic here. Specialized object has all the characteristics of general objects plus unique characteristics. What does that mean? Well, what it means is, and let's go back to a specialized object has all the characteristics of the general object plus its unique characteristics. So insect here is specialized. It has all the general characteristics of animal, such as weight, but it also has a unique characteristic such as hardness for its exoskeleton. A bee has a hardness and await characteristics, because we're using what I call chained inheritance, which is actually just multiple inheritance. So you can have a whole hierarchy of technology built on this. In fact, that's the way most of the graphical user interface programming languages work today, and we're going to be getting into that specifically soon. And then we have another class called the queen that is a specialized class of the base B. So that's the idea. That's why inheritance is. And here's what the relationship is. An insect is an animal. An animal has a weight. So this is really key, guys, because this is the is a relationship, and the has a relationship is what I'm going to be basing most of your final on, is what you're going to be able to do to differentiate that. So essentially, the is referring to inheritance. This is referring to inheritance. Guess what? You already know what has is. That's the composition that we talked about. That is composition. So an animal has weight, and weight could be another object that inside has specific variables to determine what the weight is in either kilograms, pounds, or whatever. But the is a relationship, we're talking about inheritance. So a queen is a bee, which is an insect, which is an animal that has a weight. So the queen is composed of weight because it is part of this big inheritance chain that eventually gets down to the weight object. And an insect has weight because it takes on the attributes of animal, which is where the weight is defined. A bee has a stinger size. A queen, well, I didn't put any has a in the queen. But that's the kind of the idea of inheritance, and what you're dealing with is the is a versus has a. Okay, so that slide is good. I'm going to wipe this board, and we're going to get into the proper terms that Python uses here, and then we're going to get into another example. I just want you to know these are the superclass and the subclass. I used some of them before, but in my mind, in the way I talk and the way most languages refer to these, is a superclass is a base class, and you can see here in the parentheses. And a subclass is a derived class. Now the questions in your quizzes are going to be based mostly on subclass and superclass. Hey, there are different languages that use this terminology. I know Java is one that kind of uses super and sub. I'm not for sure exactly which one. I think it's super and sub. But, when you get to more of the C-based languages, JavaScript, C++, I think Rust even goes in there. But, it's Java and Python. I just call them the rogues. They're the ones that use the different terminology. So we're going to come back, and I'm going to give you another example, and we're going to use, instead of the base class derived class, I'm going to force myself on the superclass and the subclass terminology so that you guys can internalize it as well. So I will be back soon. Okay, we're back with we're back with another example here, and let's say that we're going to build a whole technology, a whole programming language, and this is actually how they're done. Let's say like something like C# or even Java. This is how they're built. So the very bottom level of this technology, and I'm kind of giving you an example of how you can start with something small And when you're done, you have a whole programming language, such as C# and Java. So the first thing, if I were going to build this language that is based on like the way C# and Java are built, and some of the other high level, I call them super programming languages. Python is one of those, but they're more object based, so we won't get into that. You would have a super class, and that's the base class, to start your object inheritance hierarchy, because everything in C# and Java that you are working with is going to be data. That's what you're dealing with. That's all you're dealing with is data. And what form does data come into? Well, data comes in zeros and ones, but we tend to divide them up in between numbers and characters. So we could have a base class called object. And in that base class, we would build in this base class all the templating needed for any kind of data object or component even. And a component could be something, a sequence of data that actually has functions that does something. So the object can be a component or just straight up data. So we would build an object class, and then we would inherit and build the string class based on that. And we could inherit and build the char class for a character, or inherit and build the int class for an integer. Now we're going to get a little bit deeper into it. We can have a component called control. And what I'm talking about is we're building a graphical user interface language, and what we're going to have is like a form, and in that form we would have a list box, a button, a text box maybe, so you push the button, you type the text in, and you have some things that are listed in here. So this is something that is drawn. So what would inherit from object would be something that we can call a control. And a control would be something that we use to interact with the user, such as a text box, a button. And that control can inherit from object. We would create all the data necessary for what an object is, a container that has some attributes that are needed to work with anything that would inherit from it generically. And I'm being very abstract, but this is how this technology is built. So we would have a control object, and then out here we would inherit from control, and this would be a text box. And inside that text box, we would have a has a string. That would be a string, that would be composition, not inheritance. So the text box would inherit from control, but have a string inside of it so that it can hold the text that you're going to put inside of the text box. Then right here, you would have a button that inherits from control. So you would define a button and everything that's needed for a button. Well, what's needed for a button? Basically a length, width, height, and then that way you could draw the square around the button in the form, and then functions to accept an event for mouse handling for when you were clicked on the button. And let's say that you built those functions to handle for the mouse at the control level. So you could build the control at the control level, everything to handle for mouse input and keyboard input for all controls, and then you inherit button from a control, and it already has the mouse and keyboard input built for it. And the text box can just take on what's a text box. Like it could have a rectangle in it to define where the text box is drawn and what location it's at on the form, an X and Y coordinate, an integer inside of it. You could have a list box from here. A list box, one of these guys that lists things. And then finally, what else would you have? Well, a control. Wouldn't this whole thing be a control? The form? The form itself that you're putting the text box and the button inside of and the list box inside of? That would be a form object. And a form would be composed of a button. It wouldn't inherit from the button. It would have a button. And you would add it to a controls list that is inside of the form. And so the form would have a controls list where a button would be inside of it. A list box could have a string list where all the strings that go in the list box are right there. So the form would inherit from that control. And before you know it, as you go from general, and this is a very simple abstract example, to more specific, before you know it, you have a whole technology. You have the C# programming language. You have the Java programming language. And that all comes from this one little seed. That one little seed. And inside of this little seed, you would have dynamic functions that do dynamic binding. Okay, I'm going to stop right there. That's not stuff we need to get into. This is good enough to give an example of why we use inheritance and why we differentiate between the is a and the has a relationships. Because a form is a control, which is an object, but a form has a controls list that has buttons inside of it. And that's the idea. That's a perfect example of why we have inheritance and composition and what it does for us. Because I know I've referred to what changed in the late 90s when object-oriented programming came out. And that is that the software was already written before the hardware has even been envisioned in a lot of ways. Because of this, we have a map already. We can take code that's already been built in a generic hierarchy or chain of inheritance with subclasses and superclasses. And before you know it, we have a whole technology that we just need to modify a little bit of off the chain of inheritance to deal with that new piece of hardware. So this is how you write code for the future. This is writing code, for the future. And it's awesome. So do look into the dynamic binding because that's really what puts it all together. That's what destroyed Microsoft Foundation classes, MFC, it's old school programming. But object is a base class of the subclass derived class control, which is a base class of the superclass text box. Oh, no, I already messed it up. Sometimes that base and derived terminology gets into me too much. Okay, object is a subclass or a derived class. Control is a oh my God, I gotta start over. I apologize. My terms are incorrect today for some reason. Okay, let's start over one more time. The object class is the primary base class or superclass. Control is the subclass that is the derived class of the base class or the superclass object. And in that hierarchy would go. So control can be also the base class or the superclass of its subclass text box. So this control can be considered both a superclass and a subclass because it is a superclass, a base class of text box, but it is also a derived or a subclass of object. So you see how that chain kind of goes together? So list box, since it has nothing that is derived from it, and we could have a colored list box even if we wanted, or something like that, because remember when you go up that chain, You go from generic to specific. And these base class and superclass terms can be used both for one specific object, because control is both a superclass, a base class of text box, and a subclass or derived class of object. So that gives you a breakdown of what inheritance is and why, more importantly. I'm sick of this. I'm ready to have some fun. I think it's like demo time, because a lot of this stuff, I'm going to have you guys, let's just look at UML diagrams on in Google real quick, just so you know. When you are planning your inheritance hierarchy, you don't just jump in and start writing code. It's better to come up with what we call a UML diagram, and I'm going to come up with a very good example of this. So let's go to images, and then we'll talk about one that I just pick out here that looks good. Okay, this one I think looks good. No, that one's kind of silly. This one looks good. Yeah, this one's great. Okay, so in this example, what we're doing is we are mapping out our inheritance and composition hierarchy. So you can do both based on who you employ with. Sometimes the way that you do these different arrows in here, these different arrows denote whether you're using inheritance or composition. So you see this open arrow? That means that student inherits from person, professor inherits from person. But here you have a closed arrow. That means that person has an address. So I don't think they put the address filled in here. So the address should be inside of here, composed, and it would be address : address, referring to the composition part of this. And I could, because here's the deal. All the different terminology between determining inheritance versus composition with your arrows, that all changes out there. They're all contradictory. So I don't internalize them too much, other than if you are given a roadmap by somebody that's expecting a UML diagram, you follow the roadmap on how you do your arrows. And that will happen if you get in, when you get in an industry. You guys, a lot of Python programmers do not have to do this. This is more for software engineering. And a lot of Python programmers, Python is not for software engineering. You use software engineers to develop the Python language, which is not really a language. It's an interpreter built with just C. Here is the pertinent parts of this UML diagram. You notice that we have some way of denoting inheritance with an arrow. And inside a student, we have a plus, and we declare the name of the variable, and we decide what kind of variable it is. In this case, it's an integer, it's a number. And we say plus, meaning that that's a public data field, which should actually be minus. This should be minus, which means it's private. So this is an incorrect UML diagram. But it's good enough for our example. Now, when you have functions, the functions should have a plus in front of it, and you describe the function, what data type it argues, it sends, and what, if anything, it returns. And so you see the line here, data is up here, and all data that's inside of an object should have a minus in front of it, not the plus like it has here. Like over here, here's a good example of a private data field that does not have a read or write access. You have to access it through a function. See the minus in front? That's a good example of how all data fields should be. Professor, looks like it has no functions inside of it to work for professor. So address, the address object has all these variables that are public when they should all be minus, 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 with getters and setters that are public. Like here, this minus, that's not very good for them. That should be a plus. Unless you want it read only and only be an internal function, then you can make it private with the minus. But again, since Python has always been historically object-based, I mean, even now I was surprised that they didn't allow you to access private data fields that you would declare private with the 2 underscores in front, which is ridiculous. But hey, you slap on a Band-Aid and you move on with your code base, because the person who built Python at the lowest level is no longer around. So you work with what you have when you're updating the code base. So this is an example of a UML diagram. In every object, you describe the data that's inside the object with a plus or a minus in front of it, whether it is public or private outside its scope. And you describe the functions that are inside of the object. Like person has a public function called purchase parking pass. Now these are things that do something. This is code that does something. Remember, the reason for objects is so that we can hold data and we can act upon that data with a function. So UML diagram is a good way to give you a roadmap so that you are working from that generic to specific behavior. Now the base class here, of course, person, is, you know, I put my stuff on the bottom. They put it up on top. That doesn't matter. You know, depending on how you want to view the hierarchy, it's up to you. So student is is derived from the base class person. Professor is derived from person, etc. And I would imagine that person should have an address, and therefore an address field should be in here for street address, and it would be an address data type. So you would have address right here for that example. So I'm not gonna require you to really get into UML diagrams in this course, because again, this is for software engineering, and that's not what we're really worried about. But having that understanding means that you can talk with a software engineer. You can work with a software engineer, and that's very important. Okay, so let's move on to a few other things. Oh, good. We have an example of our UML diagram in here with Python. So great, we're on some good examples here. Automobile, the make, model, mileage, and the price. You see these all have the 2 underscores in front of it. So this is what I would call a more Python specific UML diagram. I don't consider this a real UML diagram. And that's why I'm not really taking too much time with it. But I would actually change this 2 underscores up front here, and I would put a minus in front of there instead, and a minus in front of model as well. And then the init function, I would put a plus in front of, and a plus in front of all these functions. But again, Python, it's not like other languages. So a UML diagram is not really... I'm seriously, I mean, yes, it's useful, but I would actually use the plus and minus terms a little bit more, and then translate it into the way Python does things, because you can see here that all functions are rightly public, declared inside of here, but I really like the plus and minus way of doing things. Okay, so again, UML diagrams, we're not going to get too far into, but you have a little bit of some background knowledge. The one that I really wanted to get to is polymorphism. So what polymorphism is for 2 like items to do something. They do something the same, but also differently. Okay, we're going to come back to that. because it's time to get away from PowerPoint and have some fun and get in some demonstration time. And so we're going to write some code. I may cheat a few ways just to get the broad strokes out to you and not build all the getters and setters. Remember, I expect that for you when you turn in your assignments. So let's begin. And we're gonna build our own hierarchy of objects, and I'm going to demonstrate to you what polymorphism is so that you can see it. Yeah, I can say it all day long, but unless you see it, it's not going to really get there in your head on what it is, because polymorphism is a big part of what makes this way of doing things, which is what I showed you on the whiteboard with an inheritance hierarchy. Polymorphism is what is basically behaviors. So polymorphism is the functions and how they behave within your hierarchy chain of objects. And I'm going to show that to you. We're going to do that next as soon as I come back. So I'll see you guys in a little bit. Okay, we're back. Let's go have some fun. I'm sick of PowerPoint. Okay, let's give you just a background of what I'm working with. I just took the last example that I did with the trivia, and we're going to modify this. I opened up main and just deleted some stuff out. Yeah, in fact, I don't think we even need the clear. I kept it because I wanted to use it, but then I deleted the import for it, and I don't want to mess with it. So we're not going to do clear. All right, now the next thing that we got is we're going to build an inheritance hierarchy with an object. Now let's start with the animal object, and I'm going to get the whiteboard up here so that we can kind of go through it together, and I can flop back and forth on the whiteboard and do some scribbling so that you can visualize a little bit better as we progress and in the demonstration. So the next thing I'm going to do is I'm going to go to my folder for my project, and this trivia queue, we're going to make that into, we're going to copy it. No, we're not going to copy it. I'm just going to rename it. I'm going to rename this animal, and we're going to open it up, and we're going to rename this animal, and we're going to get rid of all the stuff in here just so that we have something to begin with. And we're going to get rid of everything but the toString override or overload, and we're going to return just an empty string for now. Okay. Now that we have a starter, okay, let's go in, and what we're going to do, I'm wondering why this is being a stinker. Oh, because nothing's in init. That's fine. So we're going to hit save, and I'm going to go back in here, and I'm going to copy this file, and I'm going to paste it twice. And what I'm going to do is we're going to come back to these two copies later as we progress. They're going to be just kind of our template of some derived classes. And we're going to create an inheritance hierarchy. And it's going to be a small inheritance hierarchy. In fact, I think we need to make 4 copies. Yeah, 4 copies of animal. And we'll go in and we'll rename them and play with them here shortly as we progress. I'm going to give you an example of object inheritance with polymorphism. That will be it for this video. And then, of course, we're going to have some fun in our next one. So, all right, so class animal, this is going to be our very base class. So when we think about it, what we're going to have, and let's go to the whiteboard real quick, we're going to have a base class called animal. And I'm going to break out this out instead of my scribbles. So we're going to have a base class called animal. And then what I'm going to do is I'm going to have another class called cow. and another class called, we're going to call this tiger. And then another class called leg. Now this one's going to be kind of out in outer space. Okay. All right. Now this is the way the inheritance hierarchy is going to go. The animal class is going to be our base class, and cow is going to derive from it. Tiger is going to derive from it. And cow and tiger are both going to have a leg. They're going to be a one-legged cow and a one-legged tiger. Very unfortunate. We may add some more legs later, just as, you know, because we don't want to leave that poor cow and tiger with just one leg. Okay, so this is animals an object, cows an object, tigers an object, leg is an object. So this is the cow is an animal, tiger is an animal. So we're going to be very simple with this demonstration, but it's going to get complex very quick. Leg is not in the inheritance hierarchy. Leg is just going to be composed inside of a cow and a tiger. Because a cow is going to have a leg and a tiger is going to have a leg. And you're saying, well, Mr. B, don't all animals have legs? No, they don't. They all have weight, though. So we're going to create a variable in here called weight. Okay, so that's what we're going to actually do right now, is we're just going to build this animal and we're going to create the weight for it. And then we're going to build the cow and then the tiger, and then we're going to throw it all the way in together with inheritance. And we're probably going to look for some good inheritance resources and look at how the code is written a bit as we progress. But let's get the broad strokes done first. Let's get these objects done, and then we will relate them. So let's see, here we go. All right, the only thing that this animal is going to have is a weight, and then we can do an init where we pass in the weight. Very simple. That's all an animal is going to have. And what we're going to do is we're going to return the weight of is. The weight is. And then we're going to do here, we're going to do an str of self dot weight. And that's all that we're going to have for animal. Now, yes, you should be doing your set weight and your get weight. So I expect you guys to put those functions in when you're doing one of your assignments. If you're just following along with the video, fine. That's fine. You don't worry about it. So now, what other objects do I need to have? For my diagram, we need cow and tiger. And then we need a leg. So let's go ahead and in the folder, let's rename those first. So this is our first copy. Let's rename this cow. This is our next copy. Let's rename this tiger. This is our next copy. Let's rename this leg. Oh, we don't need that one. I copied too many times. Okay. So we have cow, leg, tiger. Now, let's finish those out. Let's bring them in. Let's do cow first. Okay, so we're in cow.py now. I'm just going to rename that cow. And what is something that a cow has specifically that nothing else has? And let's say number of udders. So let's add that. Self dot underscore utters. And then we're going to return has plus, and this is going to be number, self dot underscore utters. And I'm going to have to do that string. I'm going to have to stringify it. Okay. All right, so this is all we're going to have for cow. Because remember, the goal here for this demonstration is not how to fully fill out an object with everything it needs. It's how to relate them. So we're going to get the very basic example. We're going to come in here and we're going to add the leg to the cow later because we haven't even created the leg. So how can we import the leg into cow when it's not even defined? So let's go in and let's do tiger next. So Control S here to save, or file save all. This is really important for when you're doing multiple files and you try to run your program and nothing works from your changes when you realize, oh, I didn't save it, after you've already messed up and tried something else that messed it up even more. I went a little too far with that one, sorry. But that's usually what ends up happening. Okay, so tiger. All right, and what does a tiger have that nothing else really has? Let's say stripes, number of stripes. So let's say stripes, and that's going to be number 2. And we're going to say self dot underscore stripes equals stripes. Okay, you're saying, Mr. B, yes, other animals have stripes. Okay, well, let's just pretend that no other animals have stripes. But actually, it doesn't really matter because a tiger, what separates it out from other animals is that it has stripes. You might put on another object called coat that determines the coat or exoskeleton of the animal. I mean, you can drill holes on how detailed your object inheritance or your object hierarchy gets and just get crazy with it. And before you know it, you have this big mess of awesomeness that works well together and is organized. Okay, that's all we need for tiger. Oh, we had return has plus stringify self dot underscore stripes. We might not even use this because the example I'm showing you is kind of different, but we may. So you know what else the cow and tiger should have? I'm just going to go ahead and I'm going to do this. Name. We're going to add that to the cow. Let's give our tiger and our cow a name. That's easy enough. Oh, and let's do our private. There we go. And then what we'll do here is we'll return the name of the animal, the tiger. So we'll do self dot underscore name plus has, and then how many stripes. And let's do this. Stripes. Okay. All right, now let's go back to our cow. Control S, save, cow. Let's add our name here. Oh, I just messed up there, didn't I? Look at that. I didn't assign that to the utters argument. Okay, cool. All right, self dot underscore underscore name equals name. Okay, and then I'm going to have here, I'm going to do self dot underscore name plus, and then I'm going to do here plus utters. And this is just describing the name of the cow, how many udders it has. And again, you guys, I would have getters and setters for each of these depending on whether I wanted read or write access to them. All right, our cow has a name and it has output. All right. Now what we need is a leg You know what? This would be... I'm just trying to think of how that leg class would work. Yeah, let's just be silly stupid with it. Just because I'm showing composition with it. So I've opened up leg.py now, and I'm just going to rename this leg. And what do we want leg to have? We want it to have a length. And so we're going to say self dot underscore length. And then what we're going to return, we're going to say with a leg length is, and then what we'll do is we'll stringify it. Okay. Save all. Do we have our leg done? And remember, we're not going to do any inheritance here. All right. I think we have everything but actually tying these and relating them together. So let's go look at some good inheritance examples out there. And I'm just going to bring up Python and I'm going to search for Python inheritance. And let's go see what we can find. W3 schools is always pretty good. But here's an example of a base class. And they use the term child class for derived class. But you see here how the child class is declared. But what is done, the way the Python language ties inheritance together, is by putting in parentheses what object it actually inherits from. So we're going to just do this with one object. Okay, so first we're going to instantiate the object without inheritance, and we're going to look at what is actually available to us. Then we're going to implement the inheritance line of code that we see here in our example. And you know, we've got other examples out here that should be pretty good. Geeks for Geeks is always really good. So they talk a little bit about base class, derived class. So they use, I like Geeks for Geeks because they're using the terms I like, that I prefer. Here's a good example of a base class called person, and the child class, interesting, the child class, an employee that inherits from person. Okay, so let's go ahead and do this. First, what we're going to do is we're going to instantiate a cow without the inheritance, so that you guys can see what is available to it. And let's actually do one thing here. Let's add one getter. Oh wait, no, this is get. There we go. Oh, I gotta put my colon in there. I got my whiteboard thing in my way of the keyboard, so I'm kind of having issues. Okay, let's separate things around. All right, there we go. Now that's interesting. Oh, I'm being so silly. Yeah. Oops. Now I really messed things up. I don't know what that little blip was when I moved the keyboard. Okay. So def get name return self name. I was being a little silly there. All right. So let's do this. Save all. And then I think I saw a blip where I messed up length or something. There it is right there. Animal. I messed up animal. Okay. Control S. All right. So cow now has a get name. So this is the example we're going to use so that you can see. Now animal, we're gonna also add. I don't like this. Why did that do that? That's not proper. There. See, that's proper. I don't know what was going on with that. Self dot. Oh wait, I did it again. I'm thinking function def get weight. Turn self dot underscore weight. Now the reason why I'm doing getters is so that we can see what is accessible inside of animal from outside its scope, which is from main. So we're going to instantiate the animal in main, and we're going to look at what we have access to and what's inside of the object. We shouldn't have direct access to weight. We could do a public variable here called self dot. I'm just going to do something equals 0. Okay, that's a public variable, and so we're going to look at that. And then in cow, I'm going to put self dot something cow equals 0. And then there's another public data field, and again, you should never do this. It's not proper coding, but I'm doing it to show you what you have access to from outside the scope within your inheritance hierarchy. So we're going to actually inherit from animal first, and then we're going to look at what's accessible inside of animal from main. So let's instantiate animal, and what we're going to say is this is going to be eventually a cow, so I'm going to call it Betsy. But first it's going to be an animal. And what do we need to pass to the animal class? We need to pass the weight to the animal class. So let's say that Betsy is 1,100 pounds. And the reason why I have an error here is that I did not do my import. So I'm going to say from animal import animal. Okay, and we could go in the debugger and see if it's actually seeing that, but I'm not going to spend time on it. But what we are going to do is we're going to do a step into. No, we don't even need to do that. Let's see what Betsy has available to us here. And it looks like I have an indenting issue, so I'm going to go, yeah, there we go. All right. Is there something wrong with that? Yep, we might be having some issues there, but we'll see. We might have to actually set a breakpoint there just to see if it's even seeing that. So let's go here. Run Python file in the debugger. Okay, I'm going to do a step into so that I can see if it gets to the animal definition. And it does. Okay, so why does it not like the definition of animal? Okay, let's see then if we can do something with it. I think something in the definition blew it up. Okay, so let's see, Betsy dot, and we got everything that's available to us for an object a base level object in Python, but we should have those specialty functions and data types available to us because Betsy is an animal. So I should be able to grab a hold of self.something. So let's see what we got. Interesting. So that means that Betsy, an animal, this is actually having a problem in the import of the animal class, which means that I have an error somewhere in here that's not allowing it to be defined. So I'm going to pause this so that you don't go through what I'm dealing with. It might be something here. That might actually be it. Wait. W-E-I-G. Well, you know, maybe it doesn't like that for some reason. Oh, duh. That's why I wasn't defining it. Well, I found that one real quick. Okay. Yeah, you know what it is. Who's your worst enemy, right? Okay, so I did put the self in there to make it part of the object. All right. So now we should be actually, even though we went into the file, we're still having an issue there. Let's do this, save all. Let's save it. Let's run and debug again. Let's step into and see where it dies. It died somewhere, so there's still another problem in there somewhere. All right, guys, I'm going to come back and I'm going to pause it so that I can fix this problem, and I'll come back with the solution and we'll move on. I'll see you soon. Okay, we're back. So evidently there's nothing wrong. Well, it's got a warning here, so there might be a syntax issue in the object, but it's testing out fine. So we're going to move on and continue with testing Betsy. So if I set a breakpoint here, I run and debug this, and I do a step into, I should see that we have access. Now I should be able to access different things with Betsy, like something. Oh, I misspelled that. It's not showing up on the IntelliSense, probably because of that warning. Okay, let's run that. Step over, step over, step into. Okay, and now let's do this. Print Betsy dot something. Okay, so remember, this is the public variable inside of the cow, or inside the animal. So we got our 0. So we have access to the animal's internal data. It's not showing up on the IntelliSense because of that warning. I believe we can do some kind of trickery here. Quick fix. You know, we can come back to that shortly. But the idea here is that Betsy inherits, is an animal, but we haven't done any inheritance yet for the animal. We have access to this public variable. We're going to have, we can do something like Betsy dot set weight. And then we do 1000, and then print Betsy again, and we should get like 1100 and then 1000, because when we print Betsy, it's calling our toString. So, oh, did I misspell that? Let's go ahead and look at that. Oh, it's get weight. Okay, we're just gonna print Betsy dot get weight. We didn't do the setter. Get weight. You know, that can be done just the same. Okay. This time we're going to do print Betsy.getWeight just to demonstrate that we got access to these functions outside of the scope. Okay, there's our 1100. So we're doing good, even though IntelliSense is being the stinker. All right. So we have access to everything inside of animal from Betsy. Now let's implement the inheritance. And what we're going to do is we're going to go to the cow class, and we're going to say the cow inherits from animal. But for that to work, we got to inherit animal, or we got to import animal into the class. And then we can initialize or implement the animal class. But here's the problem. Well, the animal class requires us to run an init where we send the weight. So this is an issue with inheritance. And when you inherit from an object, cow, it is the responsibility of the derived class cow to implement the init function of the base class. So what does that mean? Since cow is an animal requires you to send its weight in the constructor, the init function, that means that cow now needs to get the weight of the animal. Now we can hard code it, and here's the responsibility you have when you inherit from a base class. You have to implement the init function of the base class in your init function of the derived class. So cow has to implement animal's init function. And animal's init function requires us to send a weight. And the way we do that is we use the super call. And I believe that's it for Python. I think it's super. And what we do is we invoke the init function of the base class through the call to the super, the super class. And essentially what that's doing is it's kind of a pass-through. So the cow is instantiated and the constructor runs, but since the animal's constructor also needs to run, the cow's constructor has to call it. So what we have to do is we call the super and we pass in the weight that we want it to be. Now we're going to hard code it for now so that you can look at the behaviors, because what we're going to do is we're going to do that. You use the debugger to step through what's going on, because this is your responsibility, and I expect that you guys do this. I expect that you implement the init function of the derived or the base class. So you're going to call super. I believe, yeah, I think that's correct. Yeah, super. Let's test it out, and if I got my syntax and semantics wrong, we'll fix it. So let's get in, and I'll give you a little bit more of an idea of what I'm talking about. Now Betsy is no longer going to create be an animal. Betsy's now going to be a cow. And the cow requires us, if we look at the cow class, it requires us to send in a name in the initializer. So let's go over here to the class, the cow class. And what we're going to do is send the name from main when we instantiate the cow. So the name of the cow is Betsy. Okay, now we've got probably an issue now, because we now need cow to be imported instead of animal. And it looks like we still got our problem there. Okay, no, that's fine. So we're going to have IntelliSense issues, so we're not going to be able to view that too much. Now let's go ahead and set a breakpoint so that we can see the mechanics that are going on behind the scenes. So main runs. The cow is instantiated, which means that if we do a step into here, the init function of the cow is going to be called. And we got problems. Let's do this. Let's go to the cow and let's set a breakpoint in the init function of the cow. Because we may have to make a few things. Let's do this. Instead of doing that right now, we're going to come back to that. And I may have got my syntax and semantics wrong there. Betsy, let's run and debug. Okay, that's fine. That worked. Okay, I wonder if I can do this with Python. Let's see. No, it died. It does not like that. My syntax and semantics are wrong. I misremembered that. Guess what? It's break time. I'll see you guys soon. All right, well, that was a good pausing point because this is actually where we really need to spend some time. And that is because Betsy, let's say that Betsy, we know Betsy is a cow. But Betsy is also an animal. So if we're inside of Betsy, and when I say inside, I mean that we're running code in the scope of the cow. We don't know the cow's name from main that we called the variable that we assigned to cow Betsy. Even though, you know, these are two separate things. So this is the variable name. This is just the name of the cow. So this is how we refer and work with the cow that we instantiated. And when we're inside the cow, that's the reason why we use self dot, is because we don't know it's Betsy dot something or Betsy dot utters. We just don't know the name of the cow when we're in this scope, when we're programming, when we're in our flow of running the program or the function. We don't know the cow's name. So we refer to it as self dot. That refers to the cow. Remember back to what I was talking about was, you know, when we have the cow created here, we called it Betsy, and we want to call Betsy's something variable and assign it to 0. Well, if we're inside of the cow, we don't know it's called Betsy, so we just say self dot something. So we can do something like that. We can just write a code self dot something and assign it to 4 here. That's how we refer to the cow. So instead of self, it's actually this thing, Betsy. Betsy dot something. But we're inside of it, so we don't know what it's called. Now I'm getting to my point. How do we refer to the part of the cow that is an animal, where we're in the scope of the cow? We don't know what the part of the cow that is an animal is called. How do we differentiate the scope of the cow when we're in the scope of the cow with the animal scope? If we're in the animal scope, it doesn't really matter because the cow is above us in the hierarchy. But if we're in the cow scope, how do we differentiate between the part of the object that is the cow, since also the cow is an animal? How do we differentiate between two different hierarchies? So let's even get on the whiteboard with that. So the idea is we're writing code in the cow, but how do we reference just the animal part of the cow when we're inside the code of the cow? And we use the super call, as I remembered, but what we have to do is we have to call the whole super with the open close parentheses because it's a call to the super class. It's a call to the base class. Basically, this means when I do this, super dot, and let's go into this because inside of an animal, we have something. Oh, we don't have Betsy. Yeah, we do have Betsy. That's something. That's referring to the animal part of the cow. But inside the animal, we have something. But when we're in the cow, we have something cow. And we have self.something. So we can refer to a specific part of the cow that's inside of animal. Here, this is all, something cow is only a variable that is inside the scope of cow. But here, something is inside the scope of animal. So we could also indirectly do this. Super.something is equal to 4. This is the same line as self.something, except for we're going just to the part of the animal, and we're specifically declaring that I want to access the animal scope instead of going through the cow scope into the animal scope. Because something cow, this variable is only part of the cow. This is actually inside of the animal. So we could use self.something and start with the cow self and find the something variable because something is part of the cow, because a cow is an animal. Or we can specifically say, go to the part of the cow that is an animal, grab out the something variable, and assign it to 4. So if I want to specifically call a function inside of animal from cow, like getWeight, I could say super.getWeight. Okay, and let's print that. And let's look at that in the debugger. I'm pretty sure this is going to work. I'm crossing my fingers. I'm going to remove this debugger, this breakpoint, and we're going to stop at the other. Okay, so step over. Oh, it does not like me. Okay, let's see what we're doing. Did it actually print it? Let's find that out first, because IntelliSense and the step into is not working because of that issue. So let's see what we got. Okay, what did we forget there? Let's go back to cow, utters, and name. Ah. So what it's saying is, when I created the cow, I forgot to put in the name because I added that name. So let's go fix that real quick, and then we'll get back on point to what I'm talking about. So let's go back to instantiation. Utters first. Let's say that this is a crazy cow with 30 udders. Okay. All right, let's get back on point and test this code out so that we can look at what happens with this print statement now that we got this issue resolved. And we're sending both arguments to the init of the cow. Okay, so I'm going to run a debug, and it's going to stop me there. Okay, so what we want to do is we want to go to the part of the cow that is an animal. And so we use the super call. And we're saying go to the animal part of the cow, super, and run the getWeight function. So let's do a step into. Okay, so you see, we're inside of animal now. That's our scope. So basically, when we want to go to the animal scope and we're programming inside of the animal or the cow, and we want to refer to the part of the animal or the cow that is an animal. Oh my God, I'm getting confused myself. You guys must be going crazy. But this is all part of the nightmare, because an inheritance hierarchy can be tricky, and it's kind of a different way of thinking. But what we're doing is we're saying go to the part of the cow that is an animal using the super call, because we don't know what the animal is called that is the cow. We don't have a name for it. We didn't give it a name. We're inside the scope. We're using self dot and super dot. So we're essentially calling the get weight function of the animal, and then that runs right through. Oh, well, guess what? Animal underscore animal weight. So we're going to have to, I think that's an error that I had. Get weight, self dot weight. So I'm going to have to look at that. But the cow object has no attribute self dot underscore weight. That's interesting. Okay. I'm going to play with that, and we're going to get it working so that this get weight actually happens and behaves appropriately. I'm wondering what's going on with that, because we got self weight here that's part of the animal in the base class. So that should actually be working. But here's the main part, is if we want to have access to the part of the animal part of the cow, we have to call super. That's what it does. That's what it's for. So let's get in, and what I'm going to do is I'm going to make some fixes and we're going to come back and talk about it and then run this through and get it actually working. And then we can implement the init function of the animal that is part of the cow. All right, guys, I'll see you soon. Yeah, I got ahead of myself. And this actually goes to why this is so important. I'm revealing this as we kind of go. Here's the problem: is inside of the cow, I'm calling super.getWeight, but has the animal init function ever run? No. We have not called the init function of the animal that's part of the cow. And therefore, the weight never gets defined. And therefore, when I try to go to the part of the cow that is an animal, called the super get weight, since the init function of the animal was never called, get weight is undefined. And that's where the error comes from. We're going to get to the fix here real quick. I just want you to visualize the error and why we're going to fix this and why this is required of you when you do inheritance for an object hierarchy. It has to happen. So let's go ahead and look at this again. The cow's init function runs when cow is instantiated. So I step into, and as part of the init function of the cow, I'm going to say go to the animal of the cow and get its weight. And then I immediately return self.weight. But here's the problem. Self.weight has never been defined because the init function of the animal was never called. And that needs to be done. And so that's what you have to do in the init function of the cow. You have to call its base class init, or you're going to get errors like this. Okay, so this is a perfect example of why we need to do this and what happens when we don't. And every programming language that uses inheritance, when you inherit from an object, it is your responsibility. When you inherit from any object in an inheritance hierarchy, it's your responsibility to call the base class's constructor. Every programming language is like that. Every one. It's how object inheritance works. So, how do I call the base class constructor here so that this actually works? Well, you go to the part of the cow that is an animal, and you just call the init function. And you pass in the weight. Now, we're going to hard code it now. Oh, is it weight? Yeah, it's the weight of the animal. So let's actually look at what happens here. And then we'll come back into there and see that What are you doing here, you silly thing? Jeez. Oh, just keep your settings, please, so I don't have to redo this stuff. Okay, there we go. Oh, I'm not running from main. Oh. That's why I didn't have the settings. Duh. Okay. Okay, step into. Boom. Okay, now we're doing our responsibility that every programming language requires. We are calling the init function of the base class from our derived class cow and its base class animal. So when I say super here, this is just like saying animal.init. Step into. There. Now weight is going to be defined and ready to be used so that when I call the animal again and I say get weight, that's not going to pull that's not going to wreck us. So I'm going to do another step into, and you see here, step over, no problems. We're good. All right. So then here is then where your responsibility for this becomes even greater. And we're going to be getting to polymorphism here. Because the cow is responsible calling the animal's init or constructor, what we usually do when we're doing this is if the constructor needs a specific variable, we do what's called a pass-through. So what I'm going to do is I'm going to add another variable here, and it's just going to be local, and I'm going to call it weight. And instead of hard coding this, I'm going to pass the weight through. And so now the constructor of the cow is passing through the argument that's required by the animal. And remember, this is just like saying animal dot. Even though, but it doesn't have a name, so we refer to it as super. All right. Now let's look at the behavior, how this actually behaves now. Okay, we've got to add the weight. We've got Betsy with 30 rudders, and she is, let's say she's an awesome cow. Let's say that she's 20,000 pounds. Okay, yeah, whatever. All right, run and debug. Okay, let's step into now and look at what happens. Okay, so the init function comes in, our name, and I'm trying to, why are you being this way? Go away. Okay. Our name, our udders is 30, our name is Betsy, and our weight is 20,000. We call the base class constructor with our pass-through, and we pass the weight that we're passing through the cow's constructor. And then we step into that. And the animal's constructor is now called, where weight is defined. We have completed our responsibility to our base class. And that you must do whenever you use inheritance. It's your responsibility, even if the init function has no arguments, you have to call it. Often, a lot of times when you inherit an object in other programming languages, Python even, you will have an init call that takes no arguments, a default argument that you can use for it. In this case, we do not have the ability to default where we send nothing, so we have to send the constructor something for everything to work right. Okay, so that is our cow. So let's go ahead and let's print our cow. Okay, but here's the thing that we need to do is now we have the responsibility of the cow also needing to report its weight from the superclass. So let's look at this and let's just call the print function of our cow Betsy. And it's just going to say Betsy has 30 udders. Okay, so now let's go into there and let's say print Betsy. Let's just print Betsy alone. Okay, run and debug. Okay, Betsy gets set up. We print Betsy. Let's do a step into. Betsy is reprinted. We build the string that's going to be printed here, and then we go back and it says Betsy has 30 udders. Well, guess what? We didn't we did not print the part of Betsy that is an animal. We didn't print anything about Betsy's weight, but we can do that. We can do that really easy. So we can go to our string override, not inside of, we can look at it for the animal. We can say the weight is, and you know what, since we're going to put this together, I'm going to put a space in there. Whose weight is. And this is inside the animal class. What we can do is we can invoke this from the cow with the super call and the print statement. So if we just do this, and it's going to be kind of funky looking, but if we just print super, it's saying print the animal, and if we say print the animal, it's going to call the override or overload of the string, and it's going to call this function of the animal. So I'm going to go to the cow, and I'm going to add that to my output. And I'm going to say here, plus, you know, I can't really call print here, can I? You know what? We could call print super here. That would work. That would call the underscore string class, but we can't do that when we're building a string. But this would work inside of the cow. We can print super right here. Oh, you know what? Let's do that. Instead of plus, we can just take this. No, because it returns. You know what? Let's just do this. I wonder if this would work. I don't think it's going to. But let's see. We're going to have to modify that. I'm really not sure that that's going to work. Because it needs the print statement to actually invoke the override. And we're not telling it to directly go to string. We may have to do this. We may have to go here. And we may need to, this is probably the best way of doing it. Yeah, let's do it this way because this is the best way. I know this is going to work. Let's call the supers toString function. The base class is toString function so that it specifically calls that. And then that's all done nice and neat and properly. Okay, so let's go ahead and look at what happens here. Okay, we print Betsy, step into. We call Betsy's, but if I do a step into here, it's going to call the string first, this one first. Then it's going to call this. So we may need to, our first step into maybe doing this one. Oh no, it went to the animals. So this is working. So it's calling the animals toString method. And then it's returning it back. Betsy has 30 udders whose weight is 20,000. Beautiful. That's the way you set up your objects, guys. You want things to be nice and smooth and working together so your behaviors all work out well. Let's go look at animal where there's an extra space here for some reason. I think because cow, yeah, udders. Here's the space that we need to get rid of. Oh no, let's just keep the space there. That's fine. So when we run it now, we've got, oh, I ran it from the wrong file. Betsy has 30 udders whose weight is 20,000. Cool. We're set. We have inheritance now properly implemented for a cow. Okay. So what we're going to do now is we're going to implement the tiger in the same way. So let's go to the tiger class. And we need to do a pass-through for weight. And we need to invoke the super base class's constructor and pass it the necessary weight. Okay, and then we're done. See how easy and simple that is? We take on the attributes of animal. Oh, we're not done. Animal. From animal. Import animal. And for some reason, I'm always getting this weird thing, and I'm not going to spend much time on it. I'm just going to do the quick fix. Okay. It makes it so the IntelliSense isn't popping up. That's fine. It's kind of, you know, depending on how you got your Visual Studio Code set up and your extensions and what development environment you're working in, those pop-ups may or may not work as well for you when you're working through your object hierarchy with the IntelliSense. Okay, so we inherit from animal for tiger. We pass through an it. We implement this. So then right here, let's do this plus here. Plus super. Let's call the super's output str. Done. And then what we've done is we've taken all the code that's inside of animal and made it into the tiger, tied it in with tiger, and then we added the specifics of what makes a tiger, which is its stripes. So let's go create a tiger and print the tiger. Okay. Simba, of course. Of course, guys. Seriously. Oh, we got to do from tiger import. Excuse me. And I'm just doing this because Visual Studio is being a turd. Okay, tiger. Now, what does tiger need? Let's look at tiger. Tiger needs stripes, name, and weight. So the stripes, 40 stripes. Name is Simba. And let's make this a crazy tiger. Okay. And then we're going to print Simba. All right. Let's look at that output. Import tiger, from tiger, import tiger. Wow. That's interesting. There's probably something wrong with the tiger import. I'll have to debug here. Let's see what we got. Let's run this and let's see if it's even getting into the file. Oh, it's not even getting into the file. All right, you guys, this is a break time. I'll figure it out and we'll come back. I'm wondering. That's kind of weird. Yeah, I'll see you soon. Okay, we're back. Yeah, I found out, you know, I'm in my tiger class and I just forgot to put the dot here, you know, like we did in the cow. So I just got to put the dot here. And that's why the import wasn't working, because the whole file, you know, just basically said, you got problems here. See ya. Okay, so now we're in main and we should have the ability to print Simba, Betsy and Simba. Okay, there we go. We've got it. Betsy has 30 udders whose weight is 20,000. Simba has 40 stripes whose weight is 40,000. Let's debug Simba. Okay, step into the tiger inherits from animal. Step into, we send the animal the needed weight. Then we add the specifics of the tiger, and then we print the values. And now we've got a properly put together inheritance hierarchy. It's not chained inheritance. We don't have, chained inheritance would be what I call, would be like if we were to have and I'm just going to be silly, stupid here. If we had let's say if this was a game, we had a cow that was a mad cow. So a mad cow and a, super tiger. A super tiger that in our game takes care of mad cows. And mad cows are mad because of the super tigers. Okay, whatever. But that's chained. This would be chained inheritance. So you see, we would have a whole nother object here called super tiger that would inherit from tiger. And what would be different about this tiger could be that it had a bigger or more teeth in its jaw, something like that. And what would be different with a mad cow? Well, the cow would have an insanity level of 100 added to it for different metrics within the game and how it behaves in the game or whatever. So that would be, what I call chained inheritance, or what most people refer to as multiple inheritance. And it's the only way that's possible because we can't have cow inherit from another class or this inherit from another class, because that breaks the rules for dynamic binding, and it's really a turd to do. So we don't do it at all. It's just, we don't allow it. So this would be multiple inheritance, or what I call chained inheritance. Okay, that's done. I've given you an example, and remember, I'm going to be looking when you do your inheritance. I'm going to be looking that you call the init function, and then you pass through the values that you need to pass through from whatever object you're inheriting from. This is one of the main things I'm going to be looking at when I evaluate your papers. Did you actually do that? So that's got to be there. It has to be. And you saw why we fell into a trap of when I got ahead of myself of causing that problem, because the init function is super important in Python, because it's what actually creates and defines and initializes the simple data types you have in your object. Wow, that was a lot of work just to get to polymorphism. Oh my goodness. I've got a border collie that's going a little nutty, and I'm going to head out, and when I come back, we're going to head up on polymorphism and talk about what that is, and then I'm going to demonstrate it. So I will see you guys soon for polymorphism, and then we're done. Okay, we're going to do polymorphism first, and then we're going to get into the leg composition example. That one's fairly simple. So let's do this. Let's go to the whiteboard and talk about polymorphism. Let's get some of this garbage out of the way. And what we're going to do is I'm just going to kind of describe what polymorphism is. So polymorphism is, and I'm going to, let's show that in text. This is the best definition because polymorphism, don't freak out about it, because it's what it is it's behavior of the objects that inherit from each other or have an inheritance hierarchy. And when I say behavior, I'm talking about a function or functions that work together. So when I use that term behavior, I'm talking about functions that are inside of the objects that do something. So polymorphism is when two like items, two items that are the same, two objects, when two objects that are the same yet different behave the same and different. What? What? What the heck? Okay, so let's talk about that. Two like items. Well, two like items, in this case, cow and tiger. Cow and tiger, how are they like? They're both animals. But how are they different? Well, one's a cow, more specific, and one's a tiger, more specific than its base class animal. So they're both animals, but they're also different. So how can they behave the same, but also differently? And so you make that happen through functions. And this was really helpful because if you are trying to make an action happen, you can write part of it at the animal level and finish it more specifically at the cow level or the tiger level. Let's say it's just the simple action of drawing. There would be parts of drawing an animal on the screen that you can do at the animal level, but also be more specific on how you draw that cow or that mad cow or that super tiger differently from the base class tiger or base class animal. And then, so when I use that term draw, that means doing something. So, but let's be simpler here. Let's just think about something that all animals do the same, but also differently. And that is how they eat. Okay, so then that means then that we would have the animal class. Whoops, why is that popping up? Okay, get out of here. Our animal class, what can they do the same and different? Let's say that they all eat. Eat. How do they eat? Well, how does an animal eat? Okay, well, most animals, when they eat, so we're going to have an eat function for animal. How does an animal eat? Well, opens mouth. That's how all animals eat the same. You got to open your mouth before you can eat. Okay, and then we're going to have another function. It has to be the same name. And you want to use it as the same name. How does a cow eat and a tiger eat? Well, first, the cow has to eat like an animal. First, the cow has to open its mouth. So we call the eat function of the animal first, so that we don't have to rewrite this code that opens the cow's mouth or opens the animal's mouth for both a cow and a tiger. So let's just write the code that all animals share for eating in the animal scope. Then we will write the code for how a cow eats differently from how a tiger eats. So then we're going to have it open its mouth, but a cow is going to eat grass. And a tiger is going to eat meat. Or the cow. So, how does that all come together? And that's where that super call comes in. Because when we're eating inside the cow, we got to call the base class's eat function first, so that we eat like an animal before we eat some grass. And the same thing with a tiger, we got to call the base eat function first, so that we eat like an animal before we eat like a tiger. And that's how we get the behavior of when two like objects, two animals, how they behave the same. They both have to eat and open their mouth, but they also need to do it differently. One has to eat grass and one has to eat meat. And so when you design these things, this becomes the way that you can write code for the future, essentially, and have a code base for any eventuality that within whatever you're producing, where it can add robustness and an update where you can just add to it, patch it, whatever. So let's get into actually making this happen. So let's go to the simple part, which is because the simple part is all animals eat a certain way. They all have to open their mouth. Now what I'm going to do here is we're going to just pretend that a lot of things are going on in here, but we're just going to print opens mouth. So I'm inside the animal class, and remember the behavior is a function. It does something. So I'm going to have a function. A function is what does something. And I'm going to call it eat. And that function, all it's going to do is eat like an animal. So how does an animal eat? Opens its mouth. So every animal has to open its mouth. Okay, so that's actually done. We've built the behavior how animals all behave the same. So that means that the tiger and the cow are both going to have to call that eat function. But the tiger, when it eats, so the tiger, well, let's do the cow first. Where is my cow? My cow disappeared. Here's my cow. When the cow eats, we're going to add a function. I don't think they really need to be called the same in Python. Some languages hard link the polymorphism with, okay, I'm not going down that road. You can call them different names, but just for the sake of sanity, I keep them with the same name so that I know that they should be chained together and linked. And they're in different scopes, so it's okay. They're not going to clash. So here is a cow, and what does it do? How does it eat? Well, it eats grass. Let's do a little space here. Okay, so the cow eats grass. Okay, but we're missing something here. Doesn't the cow have to open its mouth before it eats grass? So that's where we get to the part of the behavior where it behaves the same. And this is the part where it behaves differently. So what you do is you just call the superclass's eat function. So you eat like an animal first. So you eat like an animal first, then you eat differently. In fact, let's just take this whole function. Let's go to the tiger. Put it in there. The tiger still has to open its mouth, so that doesn't change. But what it does do is it eats meat, or eats the cow, or eats a cow, or eats Betsy. Okay. So opens its mouth and, so let's go back to animal. Did I put the and? Okay, let's do opens its mouth and. Okay, now let's look at what ends up happening here. Let's do this. Betsy dot eat. Okay, my IntelliSense isn't popping up because something's going on with my Visual Studio Code. Okay, now let's just look at what happens in here. It does not like my cow eat function. Oh, self. Let's go fix those. I got it good there. Tiger, self. Got to put myself in there. Okay, good. All right, let's try this again. Okay, Betsy is going to eat. So we go into Betsy. First, Betsy needs to eat like all animals. So we're going to call the animals eat function with the super call. And so Betsy needs to open her mouth. So Betsy opens her mouth and eats grass. That's it. That's polymorphism. Well, let's get the contrast. Simba.eat. Okay, so Betsy, this is Betsy eating, opens its mouth and eats grass. Now we're getting to Simba's eat. Step into, we go to Simba's eat function, the tiger, and Simba has to eat like an animal. Opens its mouth and eats Betsy. Done. Polymorphism. Actually, a very simple concept. It's just when it's not explained and you don't see it, it becomes difficult. So here's Betsy eating. Betsy is eating the same like the tiger, but Betsy is also eating differently. The tiger is eating the same like the cow, but the tiger is also eating differently. So two alike objects behaving the same, but also different. That's polymorphism. And this is the example of it. Okay, now let's go have a little bit more fun, because we have not done anything with leg. Okay, so let's go into leg. And we've got leg length. Let's do this. Let's just do a getter, get length, return length, self. Okay, now we're going to hard code this a little bit because every animal is going to have a leg, one leg. We could build a collection of legs for animals. In fact, that's what's actually what you would do, is you would have a list of legs for the animal, and your leg would be what's drawn on the screen. So we're going to have a one-legged animal. I'm going to hard code the leg in. So what I'm going to do here is I'm going to say, because I got the leg in there, it's in the folder. I'm just going to hard code it in. So I'm going to say from leg, import leg. And then my Visual Studio is being a turd, so I'm going to do my quick little ignore here. Okay. All right. From leg, import leg. Now I can create a leg here. So what I'm going to do is I'm going to say self dot leg equals, this is the composition, guys. I have a leg class. I'm instantiating a leg in the class, so I'm going to say leg. And let's just say that all animals start with a leg length of 10. And again, I'm hard coding. This should be soft coded some way. This is just for demonstration purposes. So now what I can do is I can add a get leg here. Return the leg that I instantiated. So that I can print the length using get length. And you see how I just kind of added the leg to animal? And so with that one little bit, I've updated both the cow and the tiger automatically. Done. So now the cow and the tiger have a leg. It's hard coded in how big it is, but let's go print it. So now a cow is composed of a leg. Print Betsy dot get, is it get leg? Now the get leg is just going to return the leg object. So if we look at the animal class and the get leg function, it's just going to return the leg object. What we'll have to do is we'll have to use the dot operator to get inside of the leg that we return and implement its get leg accessor so that we can print the leg that's protected inside of the leg object. Get leg dot get length. Okay, now I'm not going to demonstrate this with the tiger. Yeah, let's do it. And then I got Simba. So we get the leg inside of the, is it the animal class that it's calling? Yeah, there's only one get leg function. So, but we're using it, cow knows to find it down at the animal base class. So it goes down there with its binding. It's top-down binding. Dynamic binding is bottom-up. Okay. Actually, this would be bottom-up binding with this example. So if I'm using this example, I would say, because we're going from, oh wait, no, this is top-down. We're going from the cow goes down, we say get leg, and it knows the get leg is inside of animal. So that type of binding I call top-down binding. Dynamic binding is when you start with an animal and go out to the cow. And that we're not talking about. So let's go ahead and step into this. And this is our last bit for today on this. It looks like, oh, I didn't finish that up. Okay. All right, there we go. All right, step into, boom. Now I'm in animal scope. I get the leg. I return the leg. Okay, step over. Now I go to the leg and it's calling the get length function. Step over and we print the length, which is 10 for each one. And there's our output. And so that's an example of composition of a user-defined data type. Okay, guys, we talked about inheritance, the whys, the hows. We talked about polymorphism, the why, the how. I think we're done for this chapter. Thank you. Bye.